Good morning, engineers and scientists. Good morning. Ooh, yay. I'm honored and humbled to be here today with you with the hope, let's go forward. With the hope that you will join me in my mission of growing the next generation of engineers and scientists. It's probably no surprise to you that it took over 700 engineers to develop the iPod, which then created more than 14,000 jobs in the United States alone. Apple and its contractors currently employ over 700,000 people overseas because they can't find the 30,000 engineers that they need in the United States. In part, this is because only 1 in 3,000 eighth graders will go on in America to get a PhD in science or engineering. I don't need to tell you that our nation is in crisis mode in our need for more engineers and scientists. So this morning, I'd like to share with you what I've been doing for the past 10 years that I feel certain will help us grow more engineers and scientists. In a few minutes, I'm going to take you back to grade school. I'm going to take you there in order to plant a seed in your mind to consider joining me in working with elementary school students, not middle school students, not high school students, but elementary school students, in order to plant a seed in their young minds about the opportunities we have in this country for becoming engineers and scientists. We're going to have some fun. All right, planting the seed. So everyone should have found my business card attached to a handout on your chair. On the back of your card is a seed. I would like you to go home, get a cup, maybe a plastic cup that you can see, and put the seed, put some dirt in your cup, and the seed on the side so you can see the roots, and plant that seed and take it to your office and water it every day as a reminder that it is your responsibility to help grow the next generation of you. We need more engineers and scientists. And I'm going to show you how to do it today. But first, let me digress for a moment. You may all know that I was in the first class at the Naval Academy that graduated with women and men. In fact, Bob Condrey, does anybody know Bob Condrey? He just walked in here. He was one of my firsties. He was one of the seniors that oversaw me. I'm so surprised. Anyway, I was in the first class, and the person who planted that seed of possibility for me was my dad. He was a career Air Force officer who flew B-52s in Vietnam, and he served his country for 26 years. In October of 1975, I was a senior in high school, and my dad told me, hey, President Ford just signed the legislation into law opening all the service academies to women. What's an academy? I said. He told me it was a military university. How perfect, I thought, since I planned on joining the military, even if I'd gone to a civilian institution. I wanted to serve. So on July 6, 1976, I was one of 81 women and 1,217 men that arrived at the Naval Academy to check in on induction day. That's me, third from the right, with my 2 roommates in front and my other squad members. We all received our gear and uniforms, and this picture shows us as my squad was headed to medical to get our vaccinations. Well, that was the beginning of a long, hot day of indoctrination, which culminated with the induction ceremony, where we took the oath of office to officially become midshipmen. Afterwards, we had about an hour to say goodbye to our families. Here I am in my new plebe uniform with my Dixie cup, the hat on top. And this is my little brother, who's now 50 years old, who thinks I'm a rock star, I guess, and is asking me for my autograph. Shortly after this, I said goodbye to my family and walked into Bancroft Hall, the second largest dormitory in the world, to go into evening meal. In King Hall, the mess hall, this is where all midshipmen all at once are served. And in the This picture up here is when all 4,200 midshipmen are seated at once at tables of 12, and they're fed family style all within minutes. It's an amazing thing to see. But the other picture is when the plebes are sitting there, and that's what the plebes look like when they go down. So that's what I look like. We were seated at a table of 12. There were 9 plebes and 3 upperclassmen, and the meal was surf and turf, lobster and steak. But I was hot and exhausted and sad, and I just wanted to leave because the upperclassmen were yelling at us for everything we did. And I couldn't remember how to ask to be excused. There was a certain way to do it, and I couldn't remember, and I did it incorrectly, so I got yelled at again. And then my platoon leader stood up, and he put his knuckles on the table, and he looked at me and he said, Miss Hanley, I don't like women in my school. I don't want women in my school. And it'll be my mission to make sure you are gone before I graduate. Is that clear? Welcome aboard, I thought. Yes, sir, I said, thinking, yes, sir, you are a jerk, and I'm going to steer clear of you. Unfortunately, they put his room right next door to ours, right next door to the girls' room. So that guy made our lives miserable for the next year. Other fun things that we endured over the 4 years included the first time I went to the head, the restroom. Someone had written on the back of the stall door, "Hang it up, bitch." A female classmate of mine one Sunday walked out of chapel and was yelled at by a carload of upperclassmen driving by, hanging out the window, "Get out of our school, bitch." And these were the less vulgar insults we heard throughout our 4 years at the academy. And then it was time for Herndon. I don't know if you guys have heard of Herndon, but Herndon's a ceremony where all 1,200 plebes attempt a group effort to replace a Dixie top at the top of a 21-foot obelisk monument with an upperclassman hat. As it happens, just before our Herndon, someone started a No Girls on Herndon campaign, since no one in the brigade wanted a girl to get to the top of Herndon that first year. 2 upperclassmen made up t-shirts with NGOH, No Girls on Herndon, on them, and were selling them like hotcakes. So I decided I wasn't going to climb because, as you can see, it's pretty much bedlam. But once I was out there, one of my friends, a football player, called me and pulled me up on his shoulders. Just after he did, however, I felt a tug on my ankle, and I looked down, and one of my classmates was looking up at me, and he said, "No Girls on Herndon," and he pulled me off. I decided I was done climbing Herndon. Consequently, it took us over 2.5 hours to finish because they kept pulling the women off. And additionally, the upperclassmen had taken that Dixie cup, that hat, that plebe hat, and cut it into 6 pieces and epoxied it to the top of the monument. We didn't have a chance. Our challenges continued till senior year finally arrived when we were on top of the world. We were in charge. We had persevered and graduated. This is a special photograph of almost all the women in our class. If you look closely, I'm not in there, however. There were 55 of us. But my survival mechanism was to be one of the guys, and whenever a group of women was getting together, I stayed away. And I did the same when they were gathering for this picture, and I'm very sad about that. But I added a picture of myself with my dad giving me the oath of office. After graduation, I became a civil engineer corps officer for 10 years. Once my husband, a Navy submariner, and I had 3 children, and he was going to sea quite a bit, I had to make the very difficult decision to give up my Navy career and raise my children, a decision I've never regretted. All 3 of my children are Naval Academy graduates, along with my son-in-law. 2 of my children are here. My son is a captain in the Marine Corps. My daughter is a lieutenant in the Navy. Our 3rd child is a lieutenant. He's a submariner. Sorry, I don't know where this is coming from. My daughter and her wonderful husband, who was going to be here, but he couldn't make it. He's the assistant public works officer at the Naval Academy, and the public works officer is gone this week, so he had to be there. But the 2 of them just gave us 2 beautiful twins. My children here, Brett and Allison, are twins, and Allison just had boy-girl twins, making us grandparents for the first time in February. Very exciting. Once I left the full-time workforce, I struggled to find my next opportunity, my next challenge. I knew I wanted to make a difference and continue to serve. I worked part-time as a civil engineer, and I wrote my book, First Class, which took me 6 years to write. Then my babies started to leave the nest, and I began to substitute teach to see if I wanted to be an educator. Coincidentally, I was always called to substitute at Title I schools. Schools where at least 40% of the student population lived below the poverty level. And suddenly, another seed was planted for me. In January of 2008, the Naval Academy Dean of Academics, retired Rear Admiral Bill Miller, a former Chief of Naval Research, woohoo, we've come full circle, this is who planted my seed, was speaking at an Academy alumni luncheon. He spoke of the need to start a grassroots movement to grow the next generation of engineers and scientists. He said we needed to target young minority populations because they were the fastest growing. I immediately knew what he was talking about. I went to the principals of one of the schools where I was subbing and asked her if she'd like an after-school science and engineering program. I didn't know of one, but I was willing to create one for her school. She was elated. She'd wanted to be a physicist when she was growing up, but girls of her generation didn't go into those types of professions. So I created Y.E.S, Young Engineers and Scientists. My goals were to target elementary age students, be safe, have fun, expose students to high-level science concepts that they wouldn't typically see in elementary school, use actual scientific terminology, and use materials that you could find in the junk drawer so students could go home and replicate the experiments and essentially become the teacher, completely raising their confidence level. And I also wanted to stress engineering ethics by having them recite an oath at the beginning of every lesson. Over the last 10 years, I've created a pipeline of experiments to expose students to the wonders of engineering and science, starting at kindergarten. For K through 2, I wanted to incorporate reading using science storybooks. But when I looked around, all I could find were dry books that an atom has an electron, a proton, and a neutron. And I wanted them to be storybooks. So instead, I wrote my own. And so was born Henry the Helium Balloon, which talks about neutral buoyancy in the air, Adam the Atom, Eli Electron, Snowden the Snowman and the endothermic reaction, Molly Molecule, and Exploring Neutral Buoyancy, which is neutral buoyancy in the water, along with 7 other books. The characters are mainly girls and those from underserved demographics, because we're lacking those in our libraries as well. I knew I had to catch the children's attention and get them excited right off the bat. So I found this great experiment called Elephant's Toothpaste. And now I'm going to show you how I teach exothermic chemical reactions and catalysts to 5-year-olds. And you are all going to become kindergartners in Mrs. Disher's kindergarten class. Good morning, engineers and scientists. Good morning. Oh, you guys are good. All right, we're going to recite the yes promise. You don't have to stand up. Normally, I have my students stand up. I'm not going to make you stand up, but I am going to ask you to give me the yes sign to say, yes, I promise to do the following. I promise to respect everyone. I promise never to hurt anyone with what I have learned. Never hurt anyone with what I have learned. I promise to believe in myself. I promise to do my best. Promise to do well in math and science. I promise to be safe. Good job, everybody. Okay, today we're going to read Elephant's Toothpaste. Woohoo! Elephant's Toothpaste is a story about, I'm not going to actually read the book to you guys, but Elephant's Toothpaste is a story about Savannah the elephant and her friend Mangabee, a Mangabee monkey. And Mangabee was brushing his teeth, and Savannah wanted to brush her tusks. But Mangabee said, I don't have enough toothpaste for you. So they're like, what are we going to do? Oh, let's go ask Madame Curie, who's an African gray parrot, who's a scientist, and she has a laboratory in her tree. So they go and talk to Madame Curie, and Madame Curie tells them how to create an exothermic chemical reaction and how to make elephant's toothpaste. And today, we're going to make elephant's toothpaste too. Okay, yay! All right, you guys are getting into it. You're getting into it. Because really, kindergartners, come on, they're totally into this. All right, so I need 3 helpers. Come on, you guys are in kindergarten. All my kindergartners want to be a helper. I need 3 helpers. All right, 1, the Marine. And who's my 3rd one? Come on, 1 more. Oh, come on up, girlfriend. Yeah. Come on up. Helpers, please stand over here. All right, now we're going to be safe, so everybody needs goggles. So you're good with your glasses, ma'am. You're fine with your glasses. Perfect. All right. Oh, are those good for you? Yeah, perfect. Perfect. Okay, so for elephant's toothpaste, we need 4 ingredients. How many ingredients? 4 ingredients. And the first ingredient is the most important ingredient. Well, actually not. The second ingredient is the most important ingredient because that's our catalyst. Everybody say catalyst. Catalyst. Okay, but our first ingredient is hydrogen peroxide. Does anybody know what hydrogen peroxide is? Who can tell me what's hydrogen peroxide? Oh gosh, you guys are getting way too deep for It's an oxidizer. I'm going to use that. Okay. H2O2. You actually know the chemical formula. Perfect. H2O2. Have you ever used hydrogen peroxide? Is it in a white bottle? Normally, it's in a what color bottle? Brown bottle, right? Brown bottle, because that's a 3% solution, but this is a 6% solution, so it's a lot stronger. So only Mrs. Disher is going to handle the H2O2. Only an adult can handle the H2O2. And this is actually, I bought in a salon, a hair salon store, because it's used for bleaching hair. Okay, so we're going to use 1 cup of H2O2. Okay, scientists, are you observing anything exciting happening? No, pretty boring. Looks like, what's it look like?
Water.
Oh, hello, we are scientists. What's it look like?
H2O.
H2O, thank you. Oh, hey, hold on. H2O, H2O2. I wonder if there's a correlation there. Okay. So we have our H2O2. Who can think of what might be another ingredient? They're up here. Who's being observant? What's another ingredient we might be using? Food coloring. Very good. That comes third. What else? Dish soap. But what's the one most important thing? Who remembers? The catalyst. Oh, you guys are brilliant kindergartners. All right, our catalyst is going to be, who knows what this is? Yeast. What is yeast used for? Bread. Why? What's it do? It makes it rise. Okay, who wants to be my catalyst? Oh, Brett Disher, you're my... Brett Disher is a natural catalyst for the world. He is a catalyst. Okay, because a catalyst is what makes our chemical reaction start. It starts it up. Do you start up stuff? Oh, yeah. And you can remember a catalyst by thinking of a little kitty cat, because little kitty cats, they always start things up. Catalyst, kitty cat. Starting things up, Brett. All right, so we are going to pour into our plastic cup 1 tablespoon, and I can tell you that 1 package equals 1 tablespoon. So Brett, can you pour 1 tablespoon of yeast into our plastic cup? Pour it in the plastic cup, and then we need 5 tablespoons of H2O. How many tablespoons? 5 tablespoons of warm water works the best. 1, 2, 3, 4, 5. Okay, Brett, you are going to now be my mixer. Go mix up that catalyst very carefully. Go stand over behind that table, sir. And mix up our catalyst. Okay, what's the next ingredient? What's another ingredient? Soap, dish soap. All right, you're my dish soap girl. We need 1 tablespoon of dish soap. And I let the students do most of the work. Make sure you measure accurately. We are scientists. Good job. All the way to the top. Perfect. Pour it right in the, who can tell me what this yellow or this orange thing is?
A funnel.
A funnel. You'd be surprised how many kindergartners don't know what that is. All right, that's a lot of scientists use funnels to make it easy to pour our stuff in. All right, good job. And then, let's make some observations. Anything exciting happening here?
Turn color.
Color change. Anything else? Or bubbles indicating the presence of oxygen. Ooh, oxygen. What does oxygen start with? O, H2O. Whoops, H2O, H2O2. Okay. All right, so we have our H2O2. We have our catalyst being mixed. We have our dish soap, and we're missing our food dye. Okay, food dye. You're my food dye guy. Coming up, food dye guy. All right, we are a democratic society, so we take a vote. Your choices are green, blue, yellow, or red. Who wants green? Who wants blue? Oh, yeah, blue always wins. Who wants yellow? Never. I'm sorry, yellow. Once again, left out in the cold. Who wants red? All right, blue's got it. All right, 8 drops of blue Good job. I'm going to take that out. 8 drops. Let's count with him. 1, 2, 3, 4, 5, 6, 7, 8. Great job. Good job. Okay, now Mrs. Disher is going to do something else here. Who has a hypothesis, an educated guess about why Mrs. Disher is doing this? Anybody have a hypothesis? Why is Mrs. Disher doing that? Hypothesis, anybody? All right. We're just going to have to figure it out. All right, Catalyst Mixer, come on over. Everybody ready? Anything exciting happening? No. Are you ready? All right, so you're going to pour it in very rapidly. Ready? Into the funnel. You can put that down. 1, 2, 3. Quick, quick, quick. Whoa! Whoa! Look at our elephant's toothpaste. Super! Super, super. And I'm just going to tell you, the ambient temperature is 20 degrees centigrade. But if I put this thermometer into our foam, let's see what happens. What? Pretty soon you're going to see why it's called elephant's toothpaste, because it's going to start like looking. There we go. There's our elephant's toothpaste. There it is. Very cool. Kids go crazy. They go crazy. All right, we're already up to 45 degrees centigrade. So what happened in our exothermic chemical reaction? It did what? Did the heat go down or up? It went up, so it gave off heat, meaning it's an exothermic chemical reaction, because exo means outside and thermo means heat. And there we have it. Shall we do it again? Yeah, we're not doing it again. But normally I go with that for 3 times. Thank you to my helpers. Thank you so much. So that is how I teach exothermic chemical reactions to children. And I'm not looking to teach them the language or make them remember it. It's just exposure and just to know that engineering and science is fun. But you'd be surprised, because the following week, I'll come back and I'll just ask them, what was that word to start things up? And there's always some little kid who remembers it was a catalyst. I mean, it's astounding. It's astounding. So on your handout is a list of programs and curriculum that I've created. And I'm just going to briefly go through them with you with the hope that one or more will jump out at you and you will consider taking the time to create an after-school club or go into an elementary school once a week or start a summer camp or whatever works for you. Because all it takes is time, commitment, and enthusiasm. I have the curriculum. I have tested all these experiments. I know that they work. I know you can get them done in an hour with 25 students or less. So I have it here for you, and I'm ready to help you guys figure it out or come and train you. So elephant's toothpaste is the first experiment in the Young Engineers and Scientists series, which is geared for K through 2nd. There are 32 experiments in that series where students learn about the atom, and they create a model of, I teach them how to read the periodic table of elements, which is amazing, because when they get to 8th grade or whenever they really learn about it, they're like, oh, I had that in kindergarten. I mean, it's true. This confidence builder is huge. So we make they learn how to read the periodic table of elements, and then they make a model out of clay and toothpicks of a carbon atom. Surface tension. We're very lucky that we're near the Naval Academy. We have midshipmen who come and help us. Look how invested this midshipman is in counting, using a pipette to count drops of H2O on a penny, creating a bubble, trying not to break the surface tension on that penny. And this little kindergartner, I just love her. She's just adorable. But they're so intent. And so they learn about surface tension. Then neutral buoyancy. I use, like I said, all this scientific terminology. We don't use float and sink. We talk positive buoyancy, negative buoyancy, and neutral buoyancy. And these boys have styrofoam peanuts that they're attaching paper clips or different materials to try to get them to hover, to flink, not float or sink, but be right in the middle of a bowl of water. We teach lift and thrust with paper airplanes. We learn about drag and gravity later. And these girls were given a cup of 50 marshmallows, little marshmallows, and all the toothpicks they want. And they have to work in teams of 2. And their goal is to build the largest structure that they can with only 50 marshmallows. And let me tell you, handing 2 kindergartners a cup of marshmallows and not having them eat them is almost a bigger challenge. But there's these experiments and many others. Like I don't know if I mentioned, but the only demonstration in all of my experiments is the elephant's toothpaste. Otherwise, the kids are doing it hands-on. I try to always give them a take-home, that they make something that they can take home, so once again, they can show their parents, they can try to replicate it. And it's just been a great success. So for 3rd and 4th grade, I created a program called S squared E squared, Simple Science and Everyday Engineering. Pretty much, this series covers topics of electricity, magnetism, simple machines, heat conductivity, energy transformation, and Newton's laws of motion. There's a total of 16 experiments in this series. So you could do a 4-week program, an 8-week program, whatever works for you. You can tailor it to your what works for you. And I have written also teacher manuals for the teachers. So those are up here if you're interested in looking at them after. I have them for almost all my programs. For 5th through 8th grade, I created engineering design. This is a program where students are grouped in teams of 4. And let me tell you, for elementary school students to work in teams is a very difficult concept. They all just want to do it by themselves. They don't want to work together. So now they're being forced to, then you can't do it. If you don't work in the team, then you can't do it. So it's hard. It's something they really need to learn because that's what we do as engineers and scientists. So engineering design is students are grouped in teams of 4, and each person has a job. There's a lead engineer, a graphic designer, a materials engineer, and a quality control engineer. And teams are handed a box of stuff. And then they're given a challenge where they have to design and make a drawing. They have to build it, they have to test it, and redesign it if necessary. And they do all of this in 1 hour. And some of the challenges, the whole class gets the same challenge. But these guys have built a water filtration system. This little guy is trying, he and his team they're trying to land an astronaut, which is a raw egg, on the moon they have to hold it up to ceiling height and drop it, and it hits the ground, and it has to land without a crack or being scrambled. And this gal has created, with her team, a bionic hand. So these are some of the challenges in the engineering design program. I also created a program called Sewing in Circuits. So I teach the students to sew a very rudimentary, simple straight stitch. And I'm telling you, I have boys more excited about this program. It's so cool. So they learn to sew first, and then they sew a project. We start out with bow ties, or the girls make them hair bows. But these guys, they sew the project, and then using conductive thread made of stainless steel, this is the wiring diagram, the electrical diagram behind them. They use batteries and switch that they sew into the fabric, and an LED light. I don't know if you guys can see it, but their little bow ties are lighting up. And then using conductive thread, they create a circuit, and then they have a little switch. They love this thing. Oh my gosh, it is so, so fun. So right now I teach at Annapolis Elementary in downtown Annapolis 2 days a week. I'm their STEM teacher. And my position is funded by a Department of Defense education grant. And when they asked me to come on board, they told me I could do whatever I wanted. And I said, well, I want a 3D printer. So they bought me a 3D printer. So I have certain 5th graders who have the aptitude for it, who come down. Once they have to either be on the principal's honor roll, make the honor roll twice to be able to come down and work to use a 3D printer. So it's an incentivized system for them too. But this guy, there's an awesome free online program called tinkercad.com. And this Brandon came down and he designed his own Pac-Man. That's his design. And then he actually got to print it out. So it's super cool. 3D printing is so fun. I also like to incorporate classroom curriculum in my STEM lab. I heard that the 4th grade was studying the War of 1812. So I thought, how cool would it be if we could reenact the Battle of Baltimore? Of course, you can't have weapons in schools. So I'm like, oh my gosh, I'd seen somewhere about an air vortex cannon. So I researched it, and sure enough, we were able to reenact the British attacking Fort McHenry. So we had a team of kids who took cardboard boxes and just taped them all up, all the seams, taped them up, and then cut the holes in the side. So when you bang on the side, you get a burst of air. So one team made the air vortex cannons, and then another team built the fort. This is the fort back here, made out of paper cups and blocks. And another team made the flag, Mary Pickingill's 15-star flag, and we couldn't quite get it to hoist up and down on a pulley system. But so we had 3 different teams. We did all, and then I put on the War of 1812 overture on the overhead, and the kids went to town. It was so fun. And we did all of this in 1 hour. And I created that 2 years ago, so I've been able to do that with 4 different classrooms. It's so fun. Okay. The Gagas. 7 years ago, I started mentoring a group of girls. These are my first Gagas. Girls are great at science. And I would pick them up every Wednesday, and we'd go over to the Naval Academy with Dr. Angela Moran, who some of you may know, and we did science experiments with these girls. Or they'd come over to my house and we'd do science experiments, and sometimes I'd teach them how to sew, or I'd teach them how to cook, or we'd just go have frozen yogurt together. And these are my first Gagas. Annabelle and Dylan and Yesley and Shamira and Amanda. And I'd pick them up and we just hang out, and they're my kids. And I have 2 of my Gagas here today. Yes, Leah and Anna, can you come up? So I just want to say to you that, you may think you're just a pebble in the pond and that you'll never see the ripples. I just ran into the captain in charge of security downstairs, and she said, you know what? She knew what I was doing, and she said, I should have been an engineer. I should have been an engineer. She said, but I'll tell you what, my niece, who's 3 years old, she's going to be an engineer, and I'm going to make sure. So you never know what seeds you're planting. That person may not get to that engineering position, but their kids or their grandkids may. I met these girls in 3rd grade. Yesley, that's Yesley. In the blue top, that's Yesley. This is Yesley now. Yesley's going into 10th grade. I met her in 3rd grade. She was in my Y.E.S after school clubs from 3rd, 4th, 5th grade. And then in 6th grade, she started doing the Gagas with us. Can I tell your story, Yesley, about your dad? Yesley's family's from El Salvador. And her dad was here for 16 years driving a taxi. He got in an accident. It wasn't his fault. But he got sent back. And his whole family went back. And I lost her last August. And in November, her dad sent her and her brother and mother and little sister back. Well, now we're all caught up. Sent her back because the education is so poor in El Salvador. And so I have Yesley back. I got her back. Right? And Anna, I've known since 3rd grade. Anna just graduated from high school. And I knew Anna in 3rd, 4th, 5th grade. At 6th grade, she went to Dr. Angela Moran's STEM camp for girls at the Naval Academy. Took her over there every day. And then I lost her. And then we just lost touch. 6 weeks ago, I was in Whole Foods. It was really busy. There were 10 checkout stations going. I picked that one because there was a nice little girl behind it. And I went over there, put my stuff up on the belt, And this nice gal said, oh, hey, do you have the app? Do you have the Whole Foods app? Because you get $5 off. I said, oh, hey, can I upload it right now and use it right now? And she said, oh, yeah, sure. And then she stopped. She went, Mrs. Disher? I said, Anna? And she came running around the conveyor belt. She's like, I've been looking for you. I'm going to be an engineer because of you. I'm going to be an engineer because of your Y.E.S clubs. I'm going to go to engineering school, but I need your help. And I've been looking for you, and I couldn't find you. And I found her in Whole Foods 6 weeks ago. So this is Anna, who's going to the community college to study, get her first 30 credits, and then she's going to transfer to North Carolina State. Right? So you can make a difference. You can make a difference. And I think the key is we really have to start early. We really have to start early. All right, girls, I'll let you off the hook now. So now I'd be happy to open it to any questions that anybody has.